Welcome. We're going to do questions 167 and 168. Let's do it. They look like this. So let's get to reading. 167 states a poll of a random sample of 168 people in Sweden. So in here is 1068. Which Sweden has a total population of 9 million, found that about 75% favored government health care. Now, another poll, same in, from England, which had a much larger population, showed the same thing, about 75% supported health care. What would be a true statement? So anytime we're looking for true, we're going to just cross out anything false. No decision can be made since the populations are different and the standard deviations are unknown. So we know that's not true. We get a lot of questions in this class where the populations are different. We can still analyze them and we can deal with no standard deviations known. In fact, this part would deal with a mean question, because with a population question, and this was a proportion question, we asked a yes or no, we find the standard deviation by taking the square root of p, 1 minus p over n. And we know the proportion because they told that to us. So that's another reason why that's no good. No decision can be made since the confidence interval is not stated. Again, that's ridiculous. Okay, now these are getting to the heart of the matter. It says, since the population is larger, the English poll gives a better indication. I've never heard that in all of the class I've taught, that if a population is larger, we can get a better indication of the opinions of a larger population. So this one really does not make sense. So we're ultimately looking at A and B and figuring out which one sounds better. It says, since the Swedish poll represented a larger proportion of the population, it's more accurate. So that's interesting. We know that when we increase in, we get more accurate in comparison to our previous study. So typically, and when I say more accurate, our standard deviation goes down, which means we can approximate much closer to the mean. So if I'm trying to find the average height of the people at bogey, if I increase n, I get much, much closer to the true average as I increase n. Here, notice n is exactly the same. So for that reason, I'm going to have to eliminate B and pick A as a true statement. Since the same number of people have the same opinions, the results are equally accurate. And that's true. As long as I ask enough Swedish people and enough English people, then they should both be accurate in the same way. Now let's take a look at 168. According to the U.S. Census, the proportion of adults in a certain county who own their home was 0.7. In a simple random sample of 100 adults, 65 said they owned their home. So they actually took a sample, and 65 out of 100, so that's that. Now, this is an interesting question because it looks as if we were going to do a t-test, or excuse me, a significance test, but they don't ask us to do a significance test. So we don't really have an H sub O or an H sub A. So this actually goes to the heart of why a significance test works. It says, what is the probability of attaining a sample in which 65 or fewer own their home, assuming that this is the same as the overall population? And so they're really getting to, do you know why we can do a stat test? And stat tests work perfectly good as long as we know the information. So assuming that this is the average or the mean, the average proportion that you would get, if you ask enough people, it should be normally distributed, and it looks like I got at least 10 yeses and 10 nos, so this should totally work. Now what they've asked is 65 or fewer. So again, I could change this number to 71, but I actually want to take the proportion, and I'm trying to figure out, well, what would be the probability or the area under the curve from 0.65 over? And so that's just our regular old table A. See how this looks, just our Z table. It looks just like that. So I can use my good old AP statistics formula to do this, or I can use my fancy calculator. So the actual amount we want is 0.65, and the predicted would be 0.71 over the standard deviation. Now I said a moment ago in a proportion question, how do you find the standard deviation? Well, that's on our formula sheet a couple times here. And where else is it? Right here. So the mean proportion, mu, the proportion of the population, we think is 71%. And this is how we calculate our standard deviation. Here's the important part though. I don't want to accidentally use 65 because that's my p hat, not my p. So to find S, my standard deviation of my population would be p, 1 minus p over n, and take the square root of the whole thing. So the proportion is 0.71. If I subtracted that from 1, I get 0.29, and n is 100. So if I take the square root of all of that, I get the standard deviation of the population to be this big old number. Excuse me. Okay, so that's my standard deviation. If I plug this in, I get a z-score of negative 1.32. So to go to my table, negative 1.32, I get 0.0934. And according to table A, a z-score of negative 1.32 would give me a probability of 0.093, what did we say? 4, which is my answer B. Now let's say you're not too great at this. Could you have cheated a little bit and used the fancy calculator? The answer would be yes. You would want to go menu, stats, this is a distribution, and you want to do a normal CDF. So the lower bound in your picture is infinitely low, just a really low number. You know your upper bound is 0.65, your mu is 0.71, and your standard deviation is this number I calculated here using this formula. So that was 0.045376. Now that I have all my values in the calculator, I hit OK, and notice I get the same value, 0.093. So definitely 0.093 is my answer. Thanks for joining us.